Hello, welcome back. In this segment, I will talk about the security of puts function. As you can see, my main function is calling echo function, which in turn calls the puts function. So the input string pointer is coming from main function, which is creating an array of 4 elements, A, B, C, D are the contents. So what happens if I just compile and run this? Just pause the video and think about the expected behavior. When you put something on the screen, it essentially should print whatever is passed as input, right? So we compiled it successfully. We print it, ABCD is printing. Not a surprise, because our program is just taking ABCD as input and printing it, right? But let me recompile this code with a different compiler flag, and then you will see a different behavior. Should not use this minus F no stack protector in general. It is helping you to stop buffer overflow or format string kind of attacks. If I put prints, if I put puts, I am getting an output ABCD followed by some or random looking data. It's not typable. We can look at hex dump. It shows ABCD, right? 41, 42, 43, 44, and then some random looking data. We don't know what that is, but something weird coming out. And now you see there is some more change. Like, for example, these 2 bytes have changed. So it seems like we are able to read some arbitrary memory above the buffer of 4 bytes. Okay, as you can see, we are consistently able to read beyond these 4 bytes. More bytes we can read. Okay, that means there is some information leak possible because of something is not correct in this program. Okay, this is due to the fact that I am missing a null here in my buffer array. So let me now add one more character array, right? Let me call it secret for a moment, although you're not supposed to store secrets in raw form in the code. But let's just add a secret here, X, Y, Z. Okay, let us see whether if we recompile this thing, right, and run it, we expect the program to show ABCD followed by XYZ and something else. Yeah, you can see ABCD, and then this is XYZ. Okay, you can continue this. You will see difference. Same thing is coming here, and then some changes because of some random data. That could be the stack protector, stack canary value. Okay, so as you can see here, there's a fundamental problem. My buffer array is not terminated by null. So let me terminate it by null. Hopefully now that should go away. Usually that should do the job. Let us compile and test it. Yeah, as you can see here, now I get my 41, 42, 43 and a new line, because the puts function is supposed to add a new line whenever it prints something. So that's the reason why my prompt is coming on the next line. Like after typing ABC, the command prompt is coming on the next line. Okay. All right. So it is important to make sure that whenever you're calling puts, the input string terminates by null byte. Here is the null byte, right? So that's important. And we can even read the man page to confirm this. Man puts, if you install man, manual for puts is over here. Let's see, puts writes the string yes and a trailing new line to standard output. That's the reason why you saw a new line after it is printing. And if you go inside here, you can see the details of all other F put C, put char, and so forth. But for us, put S is the function of interest. Okay. And you can see here, it's taking a char pointer, right? Constant char pointer, yes. So there is an expectation that yes terminates, meaning the string pointed by yes terminates with a null. Otherwise, it will continue printing something until null byte is hit. It's called the string. You can see there's a word string. String means something that ends with a null. Okay, that must be part of the input. Okay. In the next segment, I will talk about gets, and there are some internal details worth learning about gets as well. Okay, puts returns a number of characters that are printed. We are not interested in that. That's why I ignored the return value. All right, that's all. Thank you very much for your attention.